I welcome you all to this course on switching circuits and logic design. If you look at the curriculum of various engineering colleges, both in the public sector and also private, you will see that this is one course which is there in almost all the UG curriculum in computer science, electronics and communication engineering and also electrical engineering. Therefore, the primary target of this course are the undergraduate students, mainly in the second and third years of study, who wants to know about this subject, switching circuits and logic design. Let me try to tell you what this course is all about. Well, today we live in a society where we see lot of electronics around us. So, all of us are carrying at least one mobile phone with us. Many of us are having smart watches, pacemakers and lot of other gadgets. There are some exercise monitoring system, health monitoring, armbands, lot of such Google glasses and so on and so forth. So, when you drive a car, every car, modern car today has a lot of electronics built into it. There are a lot of sensors which senses some real time data like your engine speed, level of oil, acceleration and so on and so forth, and accordingly takes some decision. There is a processor or a computing system which is inside that. Now, let us try to understand how do you design such a system. So, in this course we shall be talking about systems which are so called digital in nature. Broadly speaking, electronic systems can be categorized into two parts: digital, analog and something which is a combination of both, which are sometimes called mixed signal systems or circuits. Now, in digital circuits we talk about numbers. The basic circuit elements, they work on numbers. So, as part of this course, the first thing that we shall be talking about is something called number system. How do we represent numbers in a computer? How do you manipulate these numbers? Next, we shall be seeing that how this number manipulation can be realized by using some circuit elements. These are called the basic gates. And we shall also be talking about some formalism, where in a formal way how do you represent some function that you want to realize, how do you try to evaluate the various alternatives of implementation, so called design trade-offs. So, there are a lot of optimization, minimization and algebraic processing involved in this process. We shall be talking about how to design such circuits. Broadly, digital circuits are of two types: combinational circuits and sequential circuits. Combinational circuits are based on the principle that when you apply some input, you immediately get some output which is only a function of the inputs you have applied. But in case of a sequential circuit, well, even if you apply an input, the output will not only depend on what you have applied, but also on the past history of the system, right. So, we shall be looking into detail regarding this combinational and sequential circuits. How do you design them, how do you analyze them, how do you minimize them, lot of such analysis techniques we shall be studying as part of this course. Talking about slightly larger systems, when we are having a problem which is relatively larger in size, many of the methods we shall be talking about may be found inadequate. So, we need some computer aided design tools or some help from the computer systems. For that, we need to represent a system in a slightly different way, a formal way. We shall be talking about one such formalism. This is called so-called ASM chart. Well, we shall see that from this ASM chart how we can capture the behavior of the system and how we can also map the chart into the actual hardware. We shall finally be talking about how do you detect faults in such a system, because you see whenever you build something, some hardware, some circuit, there is also a chance that some faults have been inadvertently included in the system. It may be due to a design error, it may be due to some fault in the fabrication or the assembly of the system. So, we shall also be talking about some standard methods using which we can detect the presence of faults in digital systems and how we can include or incorporate the whole thing inside a chip or a package. So, overall if you talk about this course will be useful not only to the undergraduate students who are actually having a course like this as part of their curriculum, but also to the students who are slightly senior, but who wants to brush up their knowledge because they wants to apply these techniques or these concepts to design larger systems, to build more complex systems and circuits. So, I welcome you once again to this course, and I hope that the next few weeks will be a rewarding experience not only for you, but also for me while we interact during this course. And let me remind you that there will be an active forum that will be created as part of the course, where you are encouraged to ask questions regarding the courses, lectures and any other thing that you may feel relevant, and either myself or some of the teaching assistants who will be associated with the course will be more than happy to respond to your questions, to answer to your questions to the best possible extent. And just let me also tell you, the primary textbook for this course is a very standard book which is authored by Kohavi and Jha. These details will be available in the course page, so you can get all the details about it. So, with this, once again I welcome you to this course. Let us interact very fruitfully over the next 12 weeks. Thank you.